So it has a goal in mind. Now, in order to accomplish that goal, first it will do the planning. In planning, it will figure out how it will achieve that goal. So it will figure out all the action steps which needs to be taken. So that we call it compose, select actions. So it will make use of the LLM for planning. So agent will be selecting actions, that is the compose. Then agent will order, like, okay, these are the set of actions that needs to be taken. Then it will prioritize, it will order the task, and timing will also play a very important role, wherein there will be timeouts for particular task. That is very important. So हाँ जी, अच्छा एक मैं फिर से शेयर करता हूँ। अच्छा मैं फिर से शेयर कर रहा हूँ फिर। अच्छा अच्छा यू कैन सी द स्लाइड्स। ओके ओके, नाउ आई विल शेयर इट वंस अगेन। Yeah, now is it visible? Yeah, perfect. Yes, so the idea is that, okay, agent, it will do the planning, wherein it will be selecting the actions, then it will be scheduling, that ordering the actions which needs to be performed, and also allotting timing for it. And then it will be supervising, like we know that agents can perform actions, so it will make use of the tools, actions will be performed, and it will monitor the outcomes, and it will adjust the behavior. So it will reflect, like it will assess the outcomes, and it will adapt, it will re-strategize, revise the plans. So that is the supervision, supervise. So that is the orchestration. So agent, or like by default it is doing all this. So that is the orchestration. So in simple terms, orchestration is equal to, it means decision making about how task should be executed. So first we'll decide what task needs to be done, then how it should be executed, in what order, and under what conditions. So that is orchestration. So that's the control layer of agent systems. And why orchestration is necessary in agent systems? Because agent, it is already equipped with LLM, which is like a brain, which which enables its strong reasoning. It, agent is equipped with many tools. It is equipped with memory, where we can store the context, and it is equipped with knowledge. So that's why orchestration is very important. So orchestration system is like the coordinator. So agents will determine what to do first, what to do next. Stop condition met, yes, finish, otherwise retry, like that orchestration. So without orchestration, agent system will be very chaos and inconsistent. So that's the idea. So actions hap- may happen in wrong order, tools might conflict, task they might stall, results become inconsistent. Okay, so let us look at a planning a multi-step task. So we are talking about a task which involves multiple steps. So real world problems, they are usually multi-step task only. So plan my travel itinerary. So this is a task. So for that, what how agent will do is that it will perform many tasks, like check dates, search flights, compare prices, book tickets, reserve hotels, send confirmation. So these are the tasks it will be doing. Now here, first it identified what kind of task needs to be done. So this is the list which the agent identified. Then it will be planning also the order. So so agent as an orchestrator, it will evaluate possible action sequences which it can perform. Now let us suppose agent is not provided the API, then it will not be able to search flights or book tickets, for example. For to book ticket, we have to give agent certain permissions. So based on its capability, whatever it has, it will evaluate possible action sequences. Then it will execute the action plan. Then we will predict the outcomes and choose the best path. So that is what is orchestration is about. So evaluate sequence of tool calls, select path most likely to succeed. So if we talk about planning strategies, so agent can have different planning strategies. It can follow a fixed workflows wherein we can tell the agent that okay, this is the goal I want to accomplish, and this is the workflow which you should follow. So that we call it like the fixed workflow. Agent on its own, it can make use of LLM to like have hierarchical planning, dynamic planning, or recursive planning. So planning is what separates agents from chatbots. So chatbots, they are like conversational in nature. You will ask a question, they will answer, but they cannot make strategies for you. They can help you in finding the right information or resolving your queries, but they cannot cook strategies for you. So that is what makes agents different from chatbots. And also agents can not only plan strategies, rather they can act on behalf of you. They can execute strategies. And that is what agentic AI is. Agents can execute strategies. Okay, now monitoring and execution. It is very important because agents, they reflect on their actions and they adapt. So monitoring is very important because if we talk about real world, it is very uncertain where APIs they fail, data updates, user requests change, network delays we see, resources they might become unavailable. So orchestrators, so agents as orchestrator, they must track the progress of a task, of a subtask. They have to see whether the agent is going in the right direction, whether it is not drifting away from the goal. So success, failure. So they should reflect. They should keep an eye on the intermediate outputs and the system state. So monitoring functions, if we talk about, an orchestrator must answer at every step that did this step succeed? Should we continue? Should we retry? Should we change strategy? Like that. So that is what agent is. So agent as an orchestrator, it is fully active. It is continuously monitoring the intermediate outcomes, and it is always aware of the goal it want to achieve, and it will keep on reflecting on the current state and adapting, like revising the strategy, revising the plan in order to achieve the goal. So the engineering principle in place here is, see, if we execute without monitoring, then it will be a blind automation. Okay, dynamic replanning. So that is the adapt. So the ability to modify a plan while it is running. So that is something very powerful. So that is what agents can do. Agents can backtrack, not only backtrack, they can change the plan completely. They can modify the plan completely by on the fly, on the run. So orchestrators, so agents as orchestrators, they must adjust the behavior, they must adjust the workflows as conditions change. And that is what makes agentic AI truly artificial intelligence, because until now, whatever softwares we have been building, we are the one who are giving the plan. We are the one who are giving the recipe that, okay, these are the set of instructions, this you have to execute. But now in agentic AI or in artificial intelligence, agents are cooking the recipe. They are planning, they are deciding what needs to be done. So real world systems are uncertain, noisy, and incomplete. And in such scenario, agents are perfect choice because based on the uncertainty, they can replan, they can change the plan, they can adapt. For example, like let us suppose we take an example of delivery package. So initial plan was to follow the route A, but we found that in the route A there was traffic jam. So on the fly agent, it it got a signal that okay, there is a traffic jam on the route A, then it will do the dynamic replanning. So it will find a new path for you on the fly. So that is the dynamic replanning. So if we talk about conversational assistant, uh, so while talking, the conversational AI agents, they will keep on getting new signals, and based on that, they will keep on adapting. They will keep on replanning. They will keep on revising plan. So this incremental adaptation improves robustness, and that is what. And hence, agentic AI systems, they are robust in nature. They can very easily handle uncertain scenarios. They are resilient in nature. So that is something which makes them very powerful. Incremental plan execution. Okay. So agents, instead of executing a full plan at once, they break the plan into subtasks and they execute small parts. They keep on reassessing it, because executing full plan can be risky, but small parts if we execute, so that is how it works, and this is called as incremental plan execution. So the idea is that agents, how they work is that they follow the feedback loop. Like it will perceive the environment, it will receive the input signals, it will make the plan according to the goal that needs to be achieved, it will execute the plan, it will break it into sub task, action plan it will make, identify the set of tasks which needs to be executed, it will execute it, it will reflect the outcomes, it will adapt, re-strategize, revise the plan, and it will keep on doing it until the goal is achieved. So agents should think like a good problem solvers, like solve one piece, check result, decide next piece. And one more very interesting insight, if we talk about single agent is sequential in nature. It can do asynchronous processing, that's fine, but if we talk about reasoning, the planning, it is sequential in nature. So that is one point. Yes. Okay. Okay. So we completed that orchestration segment. Now we will discuss the last segment for this chapter, that is the scalability in agent systems. Okay. This is very important actually. Now scalability, if I talk about, the idea is that I have a full-fledged agent wherein functionalities I have fixed. Now that agent, it is working for 10 users. But now I want the same agent with same functionality to work for millions of users. Then the problem will be very different. So that is the scalability. Scalability means the agentic AI application with the same set of features. Now it can bear the load of 10 users. Now I want it to bear the load of 10 million users. Then many things will come into picture. And that is what we will discuss now. So agentic AI applications are very different from traditional web services, because in traditional web services, which we have been dealing with for decades, they make use of API calls. So that API call is very simple in that sense that request and response, because in an API, you will give a request, you will get a response. So no uncertainty is there. But in agents, the problem is that our agentic AI application is live, it is running on the cloud. Now, every request it will receive, that request is not like uh, it cannot just generate the response. Rather, for every request, that agentic AI application or that agent has to perform multi-step workflow, the cycle, the feedback loop. Asynchronously, it will generate. So for every request, there will be a asynchronously running feedback loop. So we can feel the uh, complexity involved, because for every request The request can be very different also. Agent will plan. It will make a different plan and it will execute tools, reflect, adapt. It has to maintain state, call multiple tools, generate long outputs, possibly interact with other agents in multi-agent architecture. So that is a very big challenge in front of us. So that is the scaling complexity. So agents are computationally heavier because in traditional web services, simple API call, any function or any logic it will business logic it will perform in the backend, it will give me the response. That's it, done. But agents, they will keep on working like a process asynchronously in the background until the goal is achieved. So they are very computationally heavy and structurally richer. So scalability is totally different. So when we are planning to scale AI, like agentic AI applications, it's very different from traditional web services. Because yeah, so what is the right way? So the right way to scale agentic AI applications. Yes, I think
Okay,
your
can you
question.
go to the previous slide, the one line.
Okay, okay, yeah,
So here you mentioned more complex than a static ML inference service. What does it mean? Like, is a part of the web
yeah.
services or it is the part of the agent?
No, no, it is different. It is like machine learning.
No.
Uh,
So this is
yeah, yeah.
attached to the agent only, static ML difference, right? It is not the part of the web service, right?
No, no, it can be the part of web service. So the idea is that in the
So,
cloud, I can have a machine learning model, and
mhm,
machine learning also like it generates a response based on the input.
mhm.
It does not do planning and all.
But
So
okay,
that, yeah,
my doubt is that anything the application that you are building, if you are calling any API or model, any model you are calling, that is kind
yeah.
of the AI or machine learn. That is a kind of agent. It is not a web service, right?
No, no,
So
no.
that
It's
got
not an
confused. The
agent.
traditional web services they never use the AI at all, right?
Yeah, like if you're using deep learning, machine learning, that is not agent.
Mm.
Agent means it has to follow the feedback loop.
So means
It has
some
to make
like
use of LLM. Yeah, yeah,
static ML reference like multiple tool. So means what? So how we will decide that is the the traditional web service like I build a application where I am based upon the natural language I am processing it like some prompt will come or some just like a chat bot through it will come. So now I after seeing the design I got really confused. What should I call it right now? I have the UI attached to it. I am putting the data, reading it, passing to a ML, passing to API, and capturing those parameter like natural language, and then executing certain flow. Okay. And now after seeing all this one, I really got confused. What should I call it? Is just like a assistant or agent or it is web service? I think this is agent, but after this it look like I call that agent or somebody can say it is not the agent at all based upon this one. So that line actually I want to draw where what the because this is just like more kind of generic the talk we are doing it, okay, but when you
hmm,
are building the system right and when you build the product it is working, but how would somebody can say it is not the agentic application at all and we are calling it agentic application based upon
yeah, yeah. So the difference you can derive the boundary line is the in order to achieve goal, if you are following the feedback loop, then it's an agent.
Mm.
Like in machine learning, to get the end goal, I just give the input, I will get the output. Nothing is involved. No tool calling is involved. No planning is involved.
Exactly. That planning makes the difference.
Yeah,
In our traditional web API, let's say we are not planning, right? Orchestra, we are not planning. We know see, it's a mostly sequential.
sequential. Yeah,
But here it can change it if this API is not available. Can I switch to another API or something, or can I skip this one? Or I can give, let's say, give you an example. Let's say we are collecting the data source from different. We are collecting the response from different data source. Let's say Splunk is not available. It could not. It can say, oh, this I could not get it, but rest are here, something like that. Or it can change. That is what is the major difference. So the API or the application or service you are developing, Mohan. You are saying that whether you call it agent or something else, right?
Right, as I was saying, my requirement was like, just get the, reading the service now ticket, or whatever the user send the email, right? That is how I get the request, but they are in the natural language. Or sometime I, we talk and then we go to the execute the code. Same, I just wrap that into a agentic code where I call the API, capture those parameter, and then execute those remaining piece of the code. That's what I did it. But based upon this one, if somebody say they, that I'm calling this agentic application, but say it is not the agent at all. Okay, it is not the agent. If agent has to maintain a tool, it need to maintain state and everything. That can also maintain the state. But the here thing is that whatever we are talking here, for me it look like, this is good concept, right? On a broader perspective, it's more generic, okay, but when you come to the real implementation, that will get the real picture. Okay, the three example, let's go to the code, see the different example. Okay, this is the agent, this is not the agent, so that we can draw a boundary, we can make our more understanding that, okay, what it is that exactly. Okay, so
Deepak
we,
wants to say something, I guess.
Yeah, yeah. Hello, everyone. So I think the objective here that we want to discuss here is how this static ML inference is coming into this traditional web services, right?
Yeah, yeah.
So if we see a
correct.
basic
That's my question only, because I never know, the static ML reference you put into the traditional web service, and it will be still web service only.
yes.
That's what.
So the thing is, whenever we want to invoke a model, right? So uh, that invocation we can actually get initiated through a web service, either using fast API or through the REST API, and the execution code of that REST API is actually using a model to get the response. So now here we have two options. One is our own algorithm. Suppose I want to add two numbers, right? So I can write my own algorithm to add two numbers. And suppose I have a model, I have a ML model to which I am giving two numbers, and it is going to give me the sum of those two numbers, where I am not using any algorithm. So here the static ML reference inference is actually talking about those traditional ML models that we used to build using different things like the SVM or base model, all those. So where we give the list of features as an input, and we are getting the classification of that as an output. So that I think we are referring here to that invocation. We can still invoke using web service, but behind the scene, it is just invoking that model and give it the feature and get the response. But here in the simple APIs, where a request has been coming, and then traditional patterns would be going to execute and get your response via some a deterministic response using some algorithms. So this is the difference here.
Perfect. Yes.
So there are too many steps I think involved here, right? It has to do lot many tasks. So is it like is it a asynchronous or synchronous service? And what kind of latency should we expect?
So the thing is whenever we from the client side, whenever we want to invoke a REST API, right? Ideally, it should be asynchronous always. Otherwise, our UI or whatever component that we are building, it is going to block for that purpose,
Mhm.
right? So usually we should go for the asynchronous REST API call only. But yes, if we want, yes, without this response, I cannot move forward. Then we can make it as the synchronous call.
Yeah, that is.
Now, regarding agents, right? Agents means whenever we are calling about this era of AI, where we are talking about agents, agentic AI, or LLMs, right? So there we are actually communicating with some service using language model, using some language where we are giving some simple text, and then the other party can understand it. Whether if it is an agent, it is going to understand our problem, define the workflows, steps, call multiple tools, all those things it can do automatically based on its intelligence, right? So this is a difference only. But we don't know what that tool is going to call. It is a probabilistic model, right? We don't know. So we have some probability that based on this response and the intelligence of our model, whatever model we are using, this is the output we should get, right? But whenever we're talking about a deterministic model, right? And when we have a ML model also, so we know that the accuracy of this model is say 98%, right? And it is giving you some score also. Okay, I am
Mhm.
this much confident that 2 plus 2 is equal to 4, right? So
So what is the typical latency here? I'm worried about that. Okay, is it like, okay, it is taking 10 minutes because it has to do planning, replanning, all those
so
things, right?
all so it won't be come into minutes. It should be less than minutes, and ideally whatever applications we are building on agents, it is good that we should get the responses within 10 to 15 seconds, not
Okay.
more than this. Otherwise we should have to build something else. You can go to any AI tools, right? It
Mhm.
is giving you some output within
Within some time, yeah.
15 seconds, right?
Yeah. Like the chat GPT we use, that's also an agentic AI application
Yes.
only,
Hmm.
wherein it is calling the tools, it is doing the web search, and
Hmm.
it is analyzing the data, generating the code, running the code.
Hmm. Yeah.
Yeah, so that's right. Yes.
Okay, thanks.
So in our traditional web services, we didn't have any planning step. Where in agentic there is a planning step, which is a major distinction.
Yes.
Yeah. Planning is, if you want to compare sub planning is nothing but the any workflow that you
Yeah.
want to execute.
So the workflow decided by the
Dynamic
agent.
workflow is not present
Yeah,
during our programming practices,
and
right?
also
So
Yes.
second
there,
thing,
yeah.
major distinction. When user input comes, previously it was well defined. Now it can be in human language, right? Let's say you are,
Yes. Yes.
oh, I am failing this, I want to go from here to here, can you guide? So
Hmm.
here agent has to first find out through LLM that, okay, what is it, has to.
Yes. Yes. So I think, yeah, we can continue. Okay. So yeah, so scalability we are discussing in agentic systems, agentic AI applications. So one of the way to achieve scalability is following the distributed architecture. So the idea is that in agent systems, we have to follow the modular structure for that, wherein every part of the feedback cycle should be a module. Like planning should be a module, execution should be a different module, and adapting, like adjusting behavior, can be a different module. So with this modular approach, the good thing is that we can focus on a specific set of functionality. We can experiment, we can iterate without touching the other module. So faster innovation we get, and with this distribution can be very helpful in agentic AI application. So the idea is that with distributed architecture, we can have task parallelization. Like we can speed up the processing. Our system can become fault tolerant. Resilience, like let us suppose our node gets failed, we can have redundant nodes, replica of nodes, which can come into the picture. We can isolate the load, like we can balance the load, prevent overload because of distributed architecture. And one very important thing is the scaling and the elastic compute. Like as the load is increasing, we can keep on adding more and more resources, compute resources, and we can keep on scaling our architecture. So hence, when we are very serious in building agentic AI applications, which should handle like millions of requests, distributed architecture is the key. And here, one more very interesting insight, be done separately, because we know that any agent AI application, it will make use of LLM. So model layer should be different. Tool execution should be taken care separately. We should differentiate. Memory storage, the context should be different, and logging and monitoring, that the observability, that should be different. So in this way, we are basically distributing the agent based on its functionality, the feedback loop, and also we can horizontally scale. Like for example, we can have multiple nodes which will take care of only models. So for models also we can have many nodes so that system will be fault tolerant, system will be able to load, balance the load. So reasoning will be taken care of independently. Similarly, tool execution, we can horizontally scale it. Memory, we can scale it. So in this way, we can achieve scalability in agent system, because in agent system, the problem is that asynchronous processing, and it can take some time also, because the workflow, it will decide, it will do so many things. With this in place, we will achieve some good results. So we will be able to achieve resilient, scalable infrastructure. So there will no single point of failure. So that's the idea. Okay, so definitely we have to make use of cloud, because cloud, we know that we get elastic compute, managed infrastructure, geographic distribution, and on-demand scaling. So our agentic AI application, it should be cloud native, because we can expand during the peak traffic, we can shrink during low usage, and we can maintain uptime globally. Okay, load balancing strategies. So we have to optimize performance and resource allocation. So the idea is that we can get millions of incoming requests. So the load balancer, it will decide how to manage the load. So how to avoid overload. So for agentic AI applications, what is the critical consideration we should keep in mind is we should separate the load. Like model inference load, we should separate it. Tool execution load, we should separate it. Memory access load, we should separate it. In this way, what will happen is that the load balancer, we will make it, we know that, okay, I want to decide the workflow. So I want to hit LLM. So I can reroute that segment of the request to the model inference nodes, wherever there is a need for tool execution. So simultaneously, all my things will be taken care of. So I am able to smartly balance the load. So that is the load balancing strategies we should consider while designing agent AI applications. So we should route complex tasks to larger models. We should route simple tasks to SLMs, like smaller models, and we should prioritize critical workflows. So the ultimate goal is that ensure that no single node becomes the bottleneck. Because if any node, it is facing some problem, we should replace it. We should isolate it. A fault we saw, we should isolate the fault, replace it with a backup. So that's the idea. Okay, parallel processing is very important. So with the architecture which we discussed, we are achieving parallel processing, because all the things are been done parallelly, like workflow, reasoning, tool execution, reflecting, adapting. We can do it parallelly. So if we took up, yeah, so that's the idea. So parallel processing, it reduces the latency, time to completion, and system congestion. Now there is a challenge also with parallel processing. Now the biggest challenge is the coordination complexity, synchronization challenges, and increase the resource consumption. In parallel processing, we might end up spending lots of tokens, like increase the resource consumption. So these are the challenges. So there is a trade-off. There is a trade-off. Like if we go for like a parallel processing to a very large extent, then challenges also we will face. So we have to maintain a balance, so that we have to keep the system simple also, and a somewhat parallel also. So that's the balance is the key. Because with parallel processing, the benefit we get is the efficiency. Our system will become very efficient. But the challenges is that cost and complexity. We might be needing more compute to support parallel processing. Okay, handling increasing workloads.
In
Yeah,
parallel processing, we also get performance, right?
yeah, performance you'll get. Yeah. performance will get.
Yeah.
Yes. Handling increasing workloads. Yeah, so the idea is clear that okay, like we deployed a agentic AI application. Now it is getting more and more usage. More users are sending requests. Now each request may involve multiple subtasks, because that we know that okay, every request will be like a goal the user wants to accomplish. Now dynamic workflow, that the goal will be broken down into subtasks. Now that subtask can be very deep. Context length will increase as more and more workload will increase. Context length will be an issue. Memory storage will be an issue. So scalable agents, they must handle all these. So increased request volume, increase the task complexity, and increase the data storage requirements. So with scalability, three things we should take care of. Increase the request volume. So more and more requests I should be able to receive. Increase the task complexity, because with every request we'll have n number of subtasks. So that is the task complexity I should take care of. And data storage requirements, that's very important, because memory also, it should keep on growing with scalability. So what are the strategies we can follow to handle the increased workload? We can go for horizontal scaling, wherein in horizontal scaling we can keep on adding more similar machines. Like let us suppose I am using a node which can store uh, like which supports like 32 GB of RAM. Now I can add multiple nodes with 32 GB of RAMs. So that's the horizontal scaling, replicating the same resources. I can go for vertical scaling, wherein a node, I am increasing its power. I am increasing its compute power, or I am increasing its RAM. So that's a vertical scaling. I can go for that. I can go for separating the models in tiers. Like I can have a separate tier for large model. I can have a separate tier for small models. And I should use the concept of cache. So caching frequent outputs is very important. With this, I will be able to handle the latency. And I should use the prioritization queues, wherein critical task should be given high priority. Because what are critical tasks? Many subtasks might depend on the outcome of critical task. So if critical task is kept waiting, it might affect the performance.
So yeah, here we are
Yeah,
talking about this caching frequent outputs.
yeah,
So
yeah,
can we discuss more detail on this? Because
yeah,
caching is what we have a some response from some input. So we store it in the form of a key value pair, right? So next time the same input will come, I should give the response, right? Immediately
yeah,
from our cache.
yeah, yeah.
So in the world of LLM,
Mhm,
how that key
mhm.
search can make using vectors, right?
Yeah, yeah,
So it's talking about something like this, or it is
yeah,
again
yeah,
only.
yeah. So here the idea is that I have decided a dynamic workflow wherein 5 subtasks I wants to execute. Now the idea is that I executed the first subtask. Now its result might be needed for the second subtask. So instead of storing that result in the RAM, let me store it in the cache, so that second subtask will be needing that result. It can directly access the much faster memory, that's the cache. That is one use case
Means
here.
while executing a given workflow, we want to share that piece of information using cache instead of memory. This is what you're
Yeah,
saying.
yeah. This is the use case I am discussing. Yeah,
But cache is actually needed when someone else is requesting this thing. Then I can save this process, right? Caching is only needed when I don't need to execute so much of algorithm and I can get the response. But
uh,
how it is useful when we want to pass some information in my workflow from step A to step D. I
Yeah.
can store the result somewhere in the DB also, right? Caching.
Yeah. So that's the thing. If you store it in the DB, latency will be the issue, and caching comes into the picture to enhance the latency, because DB IO will take time, RAM IO will take time, caching IO will take less time.
Okay, but actually, I am looking for a solution where this storage of cache can be used from some other request as well,
Yeah,
and
that is
how we are
something.
matching the keys, right?
right? Yeah. So in that respect, I
Yeah,
think.
because we are
How it is
following.
Yes,
going
yes,
to be
correct.
useful in the LLM world? The, is it again a normal key value pair only, or this key has some LLM feature where
Yeah.
I can get any key based on my input, and the the nearest key can be matched, and I get the result, something like this?
So caching here is Deepak. It's not only that with respect to LLM, it can be with respect to the tools we are using too, right? Let's say certain tools we are reusing the same response again and again. We can
Okay.
cache that. Also, LLM, as you are pointing the good one, which is the very nearest one we are searching, if it's a vector DB, in
Hmm.
that case, it can be a logic of whether I should search for the another one. Maybe the nearest one will be some other results. Maybe in that case, we may not cache. But yeah.
So caching would be behaving in the same manner as we used to do earlier, right? Some computation result we are storing, and
Yep.
if
It's,
the same computation needed again, I can use it from cache. Okay.
yep.
So, sir,
But that's a
I
good
believe
point
that
you raise.
casing for this one, it is similar to the other where just where we do for the other regular application. It will not be different as it is agentic application. Storing in the Redis or the database wherever needed. But I believe it will be similar to that how we were doing earlier. Okay. Only thing that whenever we need to query or something, the same way. It is
Yeah,
not
but
much.
one thing he raised, which is a very good and important thing, that is if you are using vector DB. So let's say there we are not finding exact match, right? We are finding which are close match. So that their casting makes sense or doesn't make sense is a question, because you never know for the next input whether the result will be same or it might be little different. So there we may not cache, I felt.
I think for vector DB, are they using vector DB or storing the embedding and then get
Yeah,
caching
we can, right?
in embedding? No, we can, but storing cache a computer result in embedding, I don't think somebody will do it or we should do it because embedding,
No,
like
no, we are
you
not
work on
storing the result
I
in
think this is
embedding.
going to come. I think this is going to come very soon, where uh, see, nowadays everybody want to do whatever they are doing .ai, right? So in caching world also uh, they should do something like this, where because getting the chunks of data from embeddings is a very costly call.
Yeah, right,
It's
right.
like it's like a processing, because normally I was testing some days before. Sometimes it takes 1 to 2 seconds to get the data. So if I'm save 1 to 2 seconds per call using this caching technique, then it's good, no?
Yeah, that's
Yes.
good. But embedding is like doing similarity search and find the result. So, like something you
Yes.
already calculated, you want the
Hmm.
same result, right? That needed. And
Same
otherwise,
result,
you go
but
into the
the key
embedding
would be
and get
different.
it, then
Yeah.
result will change, right?
But the
So
key would be different, because every time I user won't write the same set of keys, right? So key search should be, how can we build something cache where my key can be located using embeddings? So
yeah,
this is
that makes
what
sense. Like, two sentence, two user are typing, but their
hmm,
response should be similar. So neither here the key difference. So
yes,
like
कर सकते
we
हैं होंगे मेरे ख्याल से
getting the कि हाँ ऐसा शायद कुछ होता होगा लाइक मे बी लाइक कि पहले एग्जैक्ट की नहीं है वो नियर
हम्म,
बाई की है कि एक ही क्वेश्चन को अलग तरीके से पूछ रहा है और जहाँ उसका जवाब भी लगा नियर बाई हो तो आप उसको एम्बेडिंग में स्टोर कर लो फिर वहां से निकाल लो उसके
वहां से
बेसिस पे
निकालो डायरेक्ट,
हाँ
राइट?
वहां से
बी
निकाल लो
वेरी
सो
क्विक.
दैट यू कैन what you can do you can that save that unnecessary computational time.
Yep.
Yeah. Okay, so cost performance trade-offs. Now, definitely scaling agents, they are not free, because every additional token processed will add cost. Every tool call made will add cost. Every API request triggered will add cost, and memory will also add cost. So the key trade-offs when I talk about like scaling agentic AI application, if I go for larger model, then definitely we will get better reasoning, but at the cost of higher cost. If I want more context, it will give me better continuity, but at the same time, higher latency will be there. And parallel execution will be fast, but it will be more compute heavy. So there is a trade-off is there. And we have to be like very, like we have to take it very seriously, like these trade-offs. Like if budget is something which is a constraint, then we have to compromise the reasoning quality or something of that sort. So the architectural question in front of us is that where do we optimize for quality and where for efficiency? So here two things are there. Either we should go for quality or for efficiency, because we cannot get everything. So that's the trade-off. Because if we go for quality, we might have to compromise efficiency. And if we want very fast results, then we might have to compromise quality. So we have to figure out the balance. Infrastructure planning. Yeah, definitely agentic AI application you want to deploy, infrastructure planning you have to do. Like you have to
You are
decide the
on the
company.
previous screen only. I don't see your screen. Yeah.
Okay.
Now you're good.
Yeah, now it's visible, infrastructure planning.
Yes, it is.
Okay, yeah. Yeah, so infrastructure planning, like what kind of infrastructure we should have when we are planning to deploy our agentic AI system. Like the compute needs, GPU if I want, how much, because GPU is very expensive. Storage requirements, network latency, data security, very important. Monitoring systems, logging pipelines. So all that I have to consider. So infrastructure, it must support observability. That's very important, because if my application is running, I have to have something called as like open telemetry, wherein I have to observe the traces of everything, like whatever is happening. So there is a difference between monitoring and observing. So we have to take into consideration both. Like we have to observe. Observe means all the traces, auditing, logging I have to do, and I have to monitor also. Like why, like a issue happened, why it happened, what is the root cause of that, how I can avoid it from happening in the future, all that. So observability is very important in agentic AI application if you are deploying. We have to make it fault tolerance, like this retry storms, like proper timeout. That is very important. Otherwise, we end up deadlocks, retry storm. We should have circuit breakers. It should not be like our node is waiting endlessly for a response. If a node is down, redundancy, all that should be there in picture. Gradual rollout, that is very important. Canary deployment, wherein any new feature upgradation, rather than making it live for the 100% audience, let me make it live for the 1% audience, so that I can test in the real time whether it is able to handle the load or not. And if it is able to handle the load for 1% of the audience user base, I can make it 10%, 20%. I can go for blue-green deployment, wherein blue is like the live server, live deployment environment, and green is also the production environment, wherein I can do that. I can deploy my recent upgrade. And if it is working very fine, then I can make the green production environment as the one which is handling the load, and I can then make the changes in the blue. So with this blue-green deployment with zero downtime, I am able to push the rollouts. So all these are like very popular techniques which we can follow in agentic AI deployments, DevOps. Version management is very important, so that any problem with any version we can roll back. Poor infrastructure planning, it may lead to downtime, cost explosion, inconsistent behavior. Because the thing is that now, like agentic AI application you made, You did a very rigorous testing of it. So in that testing environment, it is working fine. But when it's come to production and under load, we encounter something called as Hazen bugs. Hazen bugs are something which we see only under very heavy load, because under very heavy load, like millions of load, some very unusual race conditions we will encounter that we have never seen in the normal scenario. And when we try to debug it, it disappears because of some later, what we call it, while we are debugging, we are uh, slowing down the system. So it disappears. So all that comes into picture when we are dealing with systems in scale. So cost explosion, inconsistent behavior. So yeah, so that is very important. So agentic AI system, if we are building, we have to keep in mind all these scenarios as well. So scalable agents, they require scalable thinking. Yeah, so for observability, if you are using LangChain, then there is something called as Langsmith. Langsmith is very popular. It takes care of all the observability and monitoring for agentic AI applications. So at scale, errors become more expensive, failures multiply, debugging becomes very hard. So systems, they must log decisions made, tools used, model responses, failures encountered, and latency matrices. These will be very useful. Observability will allow us to detect bottlenecks, performance tuning, cost control, and reliability improvement. So scaling without monitoring is blind scaling. Yeah, two more slides. So the best scalable systems are elastic in nature, wherein with the demand, the compute will expand. And when the demand is not there, it will contract. So, and this elastic compute, by default, we get from the cloud provider itself. Any cloud you use, elastic compute you will have. Okay, so now what patterns you should follow is, like, you are building scalable, like agent AI application, you should use modularity, modular components. For LLMs, we should have tiering, dynamic routing to balance the load, clear failure handling, because in large scale system, we cannot prevent failures from occurring. Failures can be hardware faults, software bugs, human errors, operational errors. We have to make our, we should handle it. So that is very important. So whenever we are designing agentic AI architecture, failure handling we should consider, and load aware orchestration. Yes. So yeah, this was the last slide. So we are done with this chapter 2. Yes.
Good job. Thank you. Excellent work.
Thank you.
How did you prepare this presentation this time? Using same.
Yeah.
You feeded the complete chapter 2 to the Banana Pro?
No. Chapter 2. So first I did some study and extracted the key insights.
No, I PPT preparation. PPT preparation.
Yeah, PPT, like whatever that slide I wanted, only that content I presented. I gave it to the
Banana Pro.
Banana.
Right?
Yeah.
And what is the prompt for that one you used? Like what mention?
Yeah.
What we need to mention for this kind of diagram? Like earlier that it would like graphic
Yeah.
design, right? Graphic, not
Infographic.
What is
Yeah.
this called? This type of one?
This time it is like whiteboard sketching.
Oh, they call you give the word is a whiteboard sketching. Like you give the diagram and whiteboard sketching. Then it will write. Somebody writing on the
Yeah.
board using a marker, right?
It is more realistic.
Yeah, that's correct. It looks more realistic. So,
Yeah.
but the not complete chapter you are feeding is the whatever the
No, it's
main
complete
diagram are
chapter.
there.
Yeah, it cannot do. Like, see, it will generate an image. So whatever content you want in that image, only that you have to give.
Okay. Oh, yeah. Okay.
Yeah.
Correct. Correct. That what you want to give, that you can mention it, right, and you can modify based upon that. Okay. Good to know.
Yeah, we can
Okay.
modify.
Okay. It really good. Sometime if we can have some kind of the code example as well. Okay. And for
Mhm.
different scenarios, then we can make our better understanding. Okay,
Yeah, yeah,
for this scenario we need to we go this side, so that whenever we everybody we are working professional, we are having use cases in mind, we are working in the team, so that we can visualize it. Okay, this for my situation, this be the things I need to consider in mind, because now currently whatever we are printing is very good knowledge, but it is more kind of generic, it cover everything, right? But depend
yeah.
on the use cases, something maybe it will be different, right? So
Definitely,
yeah, so we should I think generate some kind of code as well and see the different example with different scenarios. Okay.
definitely we can do that.
Okay. Okay. Thank you everyone.
Cool.
Thank you so much, everyone.
Next,
Thank you.
if
Let's meet
any
next
workshops,
week.
we will decide in that Slack channel.